All right. Good morning, everybody. Glad that you could join us today. Welcome to day 5 of the Instructor Professional Development Week here at the Camden Dream Center. So this is the second day of our network automation. So this morning we will be looking at Python and how we're gonna get it up and running, and then this afternoon we will be doing Ansible and showing you a little bit about that and how you can go in and automate things. So from our setup yesterday, we got the Windows subsystem for Linux installed with Ubuntu. We got the Windows terminals set up so that we could run the applications and that stuff. Got the Python 3 is inside of there. We installed pip so we could get to the NetMiko, all those things so that we could work with what we needed to do this morning. So as I said yesterday, if you want to do Python, you want to do it through the Windows side is fine. You can do it through Apple or anything else that's got the Python 3 stuff installed on it. I'm going to do everything today through the Windows terminal program that's built into Windows, just so you can see how that is going to work. So hope you've got your equipment with you and ready to go, so that we can at least a couple of routers or a router so that you can do something with a router and a switch. 2 routers, 2 switches is what my setup has got that I'm going to be working with today. So I'll go through and show you what we're going to do to get all of that set up. It really doesn't make any difference which routers it is, as long as they have their SSH capable, which means at the end of the iOS line, before it says .bin, it's going to have that K9 in it. The K9 indicates that it's got the security package running with it. So anything 12.2 and greater should have that on it. You really should be running versions 15 of everything, at least version 15. If you've got 2960s, that kind of stuff, it's probably version 15.0.2 is the latest version you can get. But if you have later equipment, you might be able to get some more of it from the routing side of things. The 4000 series router that I have, I'm running version 17.6 or something like that, whatever their latest version is. One thing I didn't mention to you yesterday, some of the big news out of Cisco is they found a vulnerability in the iOS XE software that people have been exploiting. There is some new updates to that, so you can get the newest, greatest iOS if you've got that security management stuff running. I'm going to send out some links or have some links added to the stuff Pastor Davis sends out next week, so you know what to expect and how you can get that get set up inside of that. So Python 3 is one of the languages that we learn, that I teach my students just a little bit about. You don't have to know anything about programming necessarily right now to do it. I'm going to give you the code for everything that you're going to do. But it's probably a good idea with your students that they go do some basic Linux. Got to know what that's about, what the commands are, how they create directories and create files and edit files and delete and move and copy and those type things. Make things executable. So they need to know a little bit about permissions and the different levels of permissions. And then we can, when we run the Python itself, there are several ways that we can go in and get that set up. So, from a programming standpoint, it might be good for your students to go through at least the Python Essentials 1 class. You can get a certification after taking that 1 class. It will take you about 8 to 10 weeks probably to go through that. but very, very good class that you can go to. It's on Skills for All, so you can run through that and have them at least know all the basic stuff that they're going to need to know for Python. Everything that we're going to do today would be covered inside of that first level of Python class, but don't have to necessarily have it for what we're doing. As you see here from in the background, I got 2 routers and 2 switches, and I got everything configured together, just like a pod is in all of our curriculum. So it's set up exactly the same way. So from yesterday, we again installed the Windows subsystem for Linux, got the Windows terminal turned on inside of it, got Ubuntu set up. Then we went in and made sure we had the latest version of Python 3. We got the pip 3 installed, and then we installed Git, NetMiko, the Visual Studio Code. We installed the Django and the JSON to HTML. So we got all that stuff ready from yesterday. So a little bit about the NetMiko that we're going to be using today. So this first group of properties here, these are things that we're going to set up everything today. So we have to know what device type that we're connecting to so that it sends out the right level commands. We have to know the IP addresses of our devices, so we have to have them set already. Interface is all that we have to have set up on those. We can do everything else ourselves then. It'll need a username and password, and we're going to talk about a couple of different ways that you can do that. You need to know what port that you're connecting to. So for us, we're going to do it all through SSH. So that's going to be on port 22 by default. But if for some reason you didn't have SSH, you don't have those capabilities on your device, then you could do it through Telnet and use port 23 for that. The secret password so that you can get into privilege mode. And then you can list commands inside of this area too. You'll be seeing us do some of that this morning as part of what we do. And then sending commands itself through NetMiko. These are some of the basic ones that we are going to use. So there's a send underscore command, send underscore config underscore set, send a file, getting it into enable mode, find the prompt so it knows what you can see the prompt, see the name of the device if you need to, save the configuration, disconnect from the call, and then send command expect and send command timing. Or these are all the ones that we'll be talking about and using today. And there are a few more of them that you can do. Primarily the send command and find the prompt are the two that we will get and use most of all today. And then we got some of these, we got a commit, check the config mode, check enable mode, exit. So basic topology, if you just have one router, one switch, that's the way that you would configure those out so that you're all on the same internal network together, and then your PC has a external network, wired, wireless, whatever you need to do to get those set up. I'm setting this up on the 192.168.1 network /24, and then you can see the IP addresses down there that they're set up for. So we're going to go through and be sure that you've got your configurations ready to go. So on your host PC, you're going to need to go down to the internet and security options. So if you find that icon in the lower right hand corner and right click on it, go to network and security or internet options. It's going to open up, not all that, whole page. You're going to open up this page. So you can see I have a wireless connection and I have an Ethernet connection both running. I'm going to go to the Ethernet connection down here, open it up, you're going to see our, again, unidentified network. It has no internet access because our devices aren't on the internet. But I'm going to move down here where it says IP configuration. Right now, yours might say DHCP. So I'm going to click on the edit button. And then it'll pop up and show you IPv4 and IPv6. And at the top, it says DHCP. And then when you click that, you can go to the manual mode. And then once you're on manual mode, then you can turn on IPv4 and then put in these addresses. So 192.168.1.10 will be its IP address, 24-bit mask. 192.168.1.1 is the default gateway and the DNS address. I can see all that configured there in the middle. So we need to get on your devices and load the basic configuration if you hadn't done that yet. So I'm showing you down here in the file what those two basic things look like. See, I'm going to have to make the changes I did yesterday. So depending on what device that you're connecting to, mine has got a gigabit 000, so I got to put one more zero on the end of that. That no shutdown was wrong yesterday. And we got to get rid of the crypto. We're going to have to go into general keys. Modulus 1024 is what I'm going to set that to. So easiest way is go in and make a copy of that. Or if you go look in your day 5 materials, so that link was on the WebEx a while ago. I can ping the devices from it. Get to the PC, okay. Get to the router. Got switch 1. Got router 2. And got switch 2. So my Ubuntu is connected out to all of those devices. And I go into like SSH. So I'm going to do it SSH. And then the username that we put on the device, admin at 192.168.1.1. It's going to ask me, do I want to save this RSA fingerprint? I'm going to just say yes. Instead of, I can say no, it logs me out, or it saves the fingerprint. If I type that, that's the default, and then I don't ever have to type it again. I usually just say yes so that it doesn't remember it. And then it asks me for the password. Let's see if my new password works. There it is. So I am SSH'd into router 1. So I can get to it through the devices. I can get through it through Windows. I can get through it just pinging through Ubuntu. And then I can also SSH into the device. So I can get in there every way that I need to. So let's go back to our switch. All right. So let's look at if you have trouble, if you do the SSH and it's not working for you, you will need to add, this is in the Ansible lesson that we're going to do this afternoon, but you'll have to go add this to that, create that .ssh location, So you can just type mkdir space tilde / .ssh. And then hit your enter key. And then you can go sudo nano tilde / .ssh / config. And that's going to open up the configuration, which is totally blank. And then you type in that host exclamation point. So we're using it for every host that we go to. We could specify as we wanted to do that. And then you got to have that hex algorithm. And we have to add that 2 different Diffie-Hellman coding exchanges. And then you have to put that host key algorithm, SSH-RSA. You can put those directly onto your config file statement if you did those. I think I show you how to do that. Okay, so we'd look up see, that's adding it to the argument. That's all, not what you're going to do, but you can go through, and after you do the SSH admin : IP address, and then at the end of it, you're going to put that -O, and then put the hex key algorithm stuff, space, -O, and then put the host key statement in there, and then it will load. I'll leave that there for a minute where you can see that if you need to type it, if your SSH isn't working. Yesterday afternoon, I was not being able to SSH. It kept giving me an error. I had to go add that host key algorithm to that statement, was what the problem was. All right, I'm going to keep going just in case you have finished with that. If not, keep working on that yourself. So you got those 4 configurations that you can build out. As I said, everything I do with my students, I build out in Notepad, just so they have this basic configuration they're going to use on every device every time they do anything. So they have that set up. Just the IP address is going to change. That I keep adding to it, but all this from that enable statement all the way down to the version 2 right there, and all of these login files, everything there minus the interface is on every device that my students do. If I don't have that basic information, I won't grade their project. They have to do that every time. All right, so we are ready to get started with the actual Python coding at this time. So there are some repositories, some things that we can go get that'll help you out. Some of the same material things that we just got. So if you have never used Git, we're going to go out to GitHub. We're going to go into my private repositories and get one called python.git. Okay, so you're going to go and copy that. It's going to tell you over there. Supplied you with quite a few different documents and things in there for you to get help with. So most of the same things that we had in the downloads that you did this morning. All right, so I'm in that Python directory now. It doesn't matter, you can be anywhere for what we're going to do in here. So here's the first Python program that we're going to go through and run. So first of all, we're going to get into the Python idle. that's built right so that it opens it up right into Ubuntu. So it's just a matter, I type Python 3, enter, and it should go into the application for me. So let me share those two things. Let's see if it'll let me put them side by side where we can see it. Makes it kind of small, fun note, sorry. Blow that up just a little bit. All off the screen. All right, so we can test and be sure that we got everything that we need in there. So I'm going to go to Python 3. And you see it immediately starts up there, the idle. So I'm in 3.10.12. I see those 3 chevrons telling me it's ready to start accepting my commands. So one of the built-in features, or what we installed yesterday inside we're using pip, was NetMiko. So I'm going to tell it, first of all, from NetMiko, import connection handler. When I hit enter, takes just a second, prompt comes back up. And then the second thing in there, I'm going to put it on multiple lines. That's probably going to error things out. Let's do that again. All right, so I'm going to create a variable called connection equals the connection handler. And then remember a while ago we said the NetMiko properties that we were going to use most of the time. So the device type is Cisco_iOS or iOS XE-XE. Either one of those are fine. IP address of the first device, my first router that I'm going to. And then I have to put my username and I put my admin. We'll talk about why that's not a good thing here in just a minute, but I got both of those properties set. Enter. Takes just a second. It's going out and trying to establish that. My authentication failed. Well, why would it do that? So you ought to be able to put in those line by line. Pull that back up for you. But just put in that first line, enter. This one's on 2 lines. So just type it all out in one and enter. Print line in one, and then the disconnect on a line. So 4 lines of code to put in, and then the same exact 4 lines of code. The only thing is you're changing the device number. You don't have to, if you stay in the same session, then you don't have to put this again. The NetMiko is already there and installed. You just go to a different IP address. And then the print command's the same, disconnect's the same. When you get ready to get out of the IDE, you have to put exit and then your brackets around it, or at the end of it. Nothing in between them. So that's the exit command to get out. So once you've done that one, you've got connectivity to all your devices. So now you're going to start scripting it out just a little bit. So I'm going to do one. I'm going to go into and open up a Nano or Vim, whatever editor that you like, you want to use. I think Nano is the easiest to start out with. Okay. And I'm going to create a show command. I can just put Nano start it blank, name it at the end, or I can put nano show-int.py, and then it will open a blank page for you. First thing that you should teach your students to always do when they're using Python is put what's known as the shebang, which is this line of code right here. So #, exclamation point, /user or USR, /bin, /Python3. Where's the location of Python for me to run from? Okay, since Linux doesn't care what the extensions, if you have extensions, that's just for human readability. This is where it knows, okay, we're going to use Python every time. Or I have to type in Python 3 and then the name of the device every time so that it will try to access it. And then this time we're just going to do everything. We're going to import NetMiko, not just the connection handler, but everything. So import NetMiko. And then we're going to name our router. So I'm going to call it router. I can call it Jim, whatever, New York. Doesn't make any difference. It's just a name. So I'm going to say router equals, and then in the squiggly brackets, and then I put in single quotes or double quotes. It makes no difference. Just be consistent. So device name in my quote equals, and then quotes, Cisco_iOS. And then you have to have a comma at the end of each one of them. Okay, comma at the end of each one of them. And then IP, set the IP, username, password, secret. And then in that router. And then we're going to make the connection. Where we did this all in one step just a minute ago, now we're doing it basically in 2 steps. So connection equals NetMiko.connection handler. Since I didn't name just connection handler, I have to put the NetMiko in front of it now. NetMiko.connection handler, and then in brackets, I'm going to put exclamation, and then router, or whatever name you called it at the top here. Whatever name you put here, you have to put that same name here. That 2 exclamation points just says, go use a variable that I just created. Go find that variable called router and put all that information into it. Same stuff that we just got through having when we did it in 1 step up here. Except this time we put the secret password with it. Okay, same exact stuff that we put up there. And then I can do the same thing with the switch. Well, before I do that, there's 4 more lines we got to look at. So I'm going to create a variable called output equals connection.send_command. And I'm going to send that show int brief. And then I'm going to tell it device equals connection.find prompt. Load that variable. And now when I print, I'm going to say device. So I'm going to put whatever the prompt is of the device. +. So add this to it. And then this single quote, \n single quote, that's just the code for go to a new line. Okay, old days of programming, we put carriage return line feed, CLF, or CRLF, carriage return line feed. For this, we just put that, and we have to have it in brackets, and it has to have that \n. So new line, then plus output. So those two variables we just filled right there, and it will print the show IP/INT brief. And then we got the disconnect. Then we got exactly the same thing on the switch, just changing its IP address. This time we're going to name it switch. Same exact outputs and same disconnect. Oh, let's see if I've got one of those for us to use. Well, let's go to, let's get out of there, exit. And we're in the folder, show INT. So that starts up Nano. Let me get that part of the code. Paste it in. Notice when you paste it, all of your indentions and stuff go away. That's important. So you have to use your mouse. I'm going to go back to router, and then all of those need to be indented one. Everything else looks good. Space those out just a little bit. Spaces don't count. So I'll put as many of those as we want to. So we get all that out of router one, and then the show command. Grab the next part of that. There's the switch command. There's the entire router command. That one a little farther so it's a little easier. All right, I'm going to save that. X. Yes, I want to save the buffer and save it as that file that I already created. And then I can go to Python 3, show int.py. All right. Router 1 responded. Those interfaces. Don't know why it failed a while ago and it worked there, because it's exactly the same command. And there's the switch that responded. So remember I told it find prompt. Okay, and then we named that. So that's why it says R1, new line, and then put the show commands. Find prompt, new line, put the show command. Whatever command that we show thing that we wanted it to do. So we can see, go in and we can put all four of those in there if we needed to. But we're writing a lot of code over and over and over, if you noticed. So all of these connection points and output and device and print and disconnect, those are the same things over and over and over. Really, the only thing that's different about that is what we put inside the switch and what we put inside the router. So, show the output there. So when we go to part 5, so kind of the same format, NetMiko, import NetMiko, the router, same exact commands. This time the command to configure the device. So it's config_commands. And then in square brackets, I have to tell it interface loopback 0. You can abbreviate, is fine. INT LO0, just like we would do if we were doing it fast. IP address, I'm going to make it 1111 with a 32-bit subnet mask. Here I'm going to establish the connection to router, or make that, and then establish that connection, and then config equals connection.send_config.set. And then there's where we call that config command. That's what we call it right there. So those two names have to match. And then we're going to tell it to print that. And then show the output device. So just like we did, show the new output and see if that works. So run it the same way. Next exercise is, so here's where we're going to start combining things. So notice here we put NetMiko, then we put the router and the basic stuff we put in the router, but now we're going to add command and output into the router. So we're just going to put all those things we did separately, we're going to put them in one command, and then we're going to do switch, do the same thing. So everything to do with routers in one command, everything to do with the switch is there. And then finally, then we can create a loop. So we're going to say 4 devices in, and whatever we named it. We had router, comma, switch. We can say router 1, R1, comma, S1, comma, R2, comma, S2. Whatever you call them, just put all those device names listed out right there. And then we're going to say command. So what do we want to run? Device.pop. So populate is what that means. And then colon command, or in brackets, command. So we're calling this command. Output equals device.pop output. There it is right there. So now we're going to make connection equals NetMiko connection handler dot device. Why the word device? Because that's what we called it here in the loop. We're telling it call this everything we just filled in this loop, grab it, and then make the connection. And then we're going to do the send command part of it. So commands equal connection.send_config.set. That's going to be the command. So whatever we had up here, commands, print the command, output connection.send.command, output, print it, and then disconnect. And then we run all that stuff. It's going to look just like it did a while ago. Only difference this time is we went in and added another loop back to it. And we added some different VLANs to it. So now we're making configuration and then showing us what we did. All right, part 7. I find myself using this one the most, probably. So I'm going to configure a router and a switch. So this time, same exact stuff, but the command is router_config.txt. So I'm going to go read a text file to get the commands out of it. Read a text file to get the commands. Well, where do I get a text file? What's in it? Inside that Python, you're going to see there should be a router config, router config.txt. Okay. Router_config.txt. That's if I spell it right. So concatenate that so I can see it. So that's everything that I'm adding to it. So the same host name, enable. I turned on the encryption, no IP domain lookup, put a banner in it. That what I'm putting in the banner itself, setting a domain. Here's the crypto key, username, all the same stuff that we've been doing. We're turning on unicast routing, setting up RIP with a process ID of 1, loopback interfaces, IPv4 address, IPv6 address, setting the link local address, and then putting it in the RIP1. So if you haven't done RIP NG, RIP next generation, that's what this is doing. That's RIP NG that we're setting up in here. Setting up the gigabit 00, whatever it's going to be. In my case, it would be 000. Set the addresses that it needs to be. Again, same things you would normally go in and type in. And then I can see router RIP version 2, no auto summary. I can put those networks that we created. I could set a static route, since there's only one way to go, a IPv6 static route, and then the end command. So when I run that, it's going to go grab that line by line and run the entire configuration. I don't have to type it out. Whatever your students have done in Notepad, that's what they're gonna tell it to go print out. Same thing for the one in the switch. Same exact thing down in this part. Nothing in that side of there has changed. Part 8 then is a kind of a cool one. We're going to create a web application. So we're going to use Django. So we got to install those if you didn't do them already. And then you're going to create the web page. So Django-admin start project. And here's the name of the project. When you do that, it's going to automatically create that for you. So I can see the end of that. And then I can do this git clone, and it's going to go grab some tools that we need. And then I can put this export, so it puts it into the path. So I can see those. So you got several steps. You just go through and set those up. Finally, you do that basic stuff. You're going to see that this web page will come up in your browser or any browser that you go to. And then you're going to actually go in and create this web page. Pretty big, a lot of code in that when you save it. And then when you decide to run it, this is the output that you're going to get. You're going to get all of your interface information in a web page, but in a table. And then you could go set that to refresh ever so often. So right there on your computer screen, you could be seeing all of the interfaces on your devices that are out there and their status. Same exact thing that DNA Center does that we looked at yesterday. It told us about all of our devices and if they could ping successfully and what their IP addresses were and the status of them at the time. Same exact thing this is telling us. We just created our own free version of DNA Center, part of DNA Center. So I really like doing that exercise and watching it work. All right, part 9. Then we're going to go in and do an SSH. This time I did it in the code application instead of doing it in Nano. So I'm going to create a file called post.txt. And then I'm going to go into it and put these 2 IP addresses, or however many devices you're connecting, put all their IP addresses in that one. And then I'm going to create a new file called credentials. And you can put any type of an extension on there that you want to. Pi just means it's going to create a Python inside of it. All that's going to be there is usernames, password, and secret, so that we don't show those on the screen. Better option if you want to make this an encrypted file, then you're going to set it to be credentials.ini. INI right there. And then that encrypts that file. put the same information inside of it. And then when I get ready to run this backup config ssh.py, so I'm going to put the shebang, import credentials, import netmiko. It could be switched, makes no difference. And then I'm going to go retrieve it. User, instead of putting username, I just said user, credentials.username. Pass, credentials.password. Sec, credentials.secret. Device equals open.host.txt. So the IP addresses. For line in devices. Connection, netmiko handler. Device type. Cisco IP, it says line. Where did it get line from? Right here. So I'm going to go read a line from this host file that I just created. Because here it says devices. So tell me the first line of devices. Username, password, all from these secret ones that we did. So none of our IPs, none of our private information is inside the coding that we're going to look at, making it more secure. We're going to run some commands, show run, find the prompt, open the file, device, plus, and then now it says file object equals open device plus dash config.txt. So whatever the name of the device here, and then this W says give this write capabilities. If I put an R, then it would read only. W, read and write. And then file object dot write config. Write the show inside of there. And then save it. So that's going to create a brand new file called router.config.txt and switch.config.txt, and put them in the same folder that you're running from. If for some reason you don't have SSH, which I wouldn't say you probably are doing that all right, then this is the way that you would go in and set it up. You got Cisco_iOS_telnet. That tells it a different name to do. Host name, whatever the host name of your device is, or the IP, you can put IP address if you need to. Port, then you're going to set that for the telnet port, 21. And then put your information that you're going to do, or pull them from the other file, or excuse me, 23, not 21. One brain dead. So that's just a little something you can do extra if you wanted to telnet. You can skip that part of it. Here's a backup a configuration file using telnet. How that would go through and run, do the same thing, doing the same thing through telnet that we do through SSH. So I'm going to give you the rest of the morning to go in and work on those, see what you can get figured out. And then we will meet back here at 1 o'clock today and start working on Ansible for just a little bit. Any questions I can answer? All right, then. I will, if you have questions, please contact me. Come back through the WebEx. I'll keep it running. And I will see you back here at 1 p.m. today. Enjoy using Python. All right, good afternoon. Any questions about Python stuff that you worked on? All right, I presume from your silence that you're golden. So let's talk about Ansible. So Ansible is a open source program that allows us to do automation. The deployment, orchestration, provisioning, does everything all in one tool. It's based on using the YAML programming language. So now we've learned Python this morning. Now we're going to learn YAML this afternoon. Pretty much the same thing, just a little formatting that's different about it. This is an agentless program, meaning I don't have to install software on the end to make it work. I just have my software. I could have it on the program on a server somewhere. I could write the playbooks and keep them on my computer somewhere, and then push all of it out to a device and configure it whatever I need to do. So agentless is a good thing for us. We do these by building what's known as a playbook. Playbook has different plays. A play is nothing more than an operation to perform. Like we were doing this morning, we changed the IP address or created a new VLAN. And then we did a new play that has us get the results. And another play that makes us display it on the screen. And then another play that makes it save it to a file for us. We have all these different plays that we want to run on different types of devices all at the same time. So you can go through and read the document that's in your Ansible. That's where this is at. It talks about some of the things we just talked about. Advantages, some of the terms that it's going to use. I'll talk more about those as we do it. So, the YAML language, yet another markup language is what that stands for. But very simple language. It's very, very similar to Python, but less words. Okay? It's everything that's in here is built strictly on key value pairs or on a list. Nothing else gets added to it. It's either in a key value pair or it's built inside of a list. We can nest any of those together. So we may have a key value pair and the value is a list of things that we could set up to it. So those things may be all nested together. If you see anything that's got the hyphen, the dash, whatever you want to call it, that tells you that it's a list. Without that, it's not a list. That's just a key value pair, a dictionary. So dictionaries and lists are what we're gonna do. So it's showing you some examples there of what they would look like. Does YAML have a shebang like Python does? Yes, but not the same thing, not the same way. For this one, for YAML, you always have to start the file with 3 dashes. You have to end the file with 3 periods. 3 dashes at the beginning, 3 periods at the end. That signifies this is going to be YAML. So we start off, we have dictionaries here. Device name is router 1. Next entry, model, colon, ISR, whatever, serial, colon, what it's going to be. Interface, colon. And now under interfaces, we have a list. So as I can see that dash. Name, gigabit 000, its description. Name and description, name and description. And then we go back to our list. So notice the way that it's indented. Everything under interfaces is indented once. When we want to go back, then we go back to the indention. The indentions are very important. So we're back to the key dictionary, location, contact name, anything, whatever you want to put in there, you can do it. There's another examples. So we go in and we call it task. Task means play. So we have in that list a play that says get the running config. We have a play that says save the output to a backup folder. So you see, these are lists. Inside the list, then, here's the task is I'm back up first. First thing we have is a list. Inside this list for backup routers, we have dictionaries. Inside this dictionary entry, we have a list that has a dictionary inside of it. And then we have another list that's got more dictionaries inside of it. So these are all these things are just the way they're nested and the way that they get indented. Very important. If it's not indented right, it'll fail. All right. As you build Ansible, there are 3 files that you have to make. Okay? 3 files that you have to make. The first one is called the Ansible config file. Okay? The Ansible config file. And it can be saved in several different ways. Okay? We can save Ansible config as an environmental variable. So we can put that into our programming statement right from the beginning if we got something to do. I can save the ansible.cfg in the current directory that I'm using it in. That's what the one I'm going to have you do. I could save it in the home directory. What signifies a home directory? That tilde at the beginning. Right there, that tilde says, in my home directory, find .ansible, a hidden file, ansible.config. Just because it's hidden, Ansible can still find it. And then if I can't find it in my home directory, then go look out in the etc ansible.cfg. So it's just going to go one in that order, looking for a file, its configuration file. Again, for what we're going to do, I'm going to put it we're going to create it in the home directory every time. For today, you can put it in the home directory, but it's exactly the same file that you're going to put in I'm going to put it in my current directory, but it's the same file that I would put in home directory, and the same one that I could put in the etc files. So it's no big deal, wherever you want to save things from. So as you start and build that file, the very first thing right out of the bat, you have to have the word defaults in square brackets. Okay, it has to start with defaults. And then you can set the variables that you want to inside of here. The ones that I'm telling you about, these are the most common ones that you should set every time. This should be the file that you build every time you build it. So the first one is called the inventory. Where is my host file? The host file is like we did with the host.txt this morning. And we put IP addresses and stuff in it. That's what the host file is here. It's going to tell us the name of the device, the name of the IP address, and other variables and things that we want to add to it. So we can put that wherever we want to put it. In our case, we're going to tell it to put it in the dot, meaning our current directory, / inside an inventory folder directory, / and then name it host. No extensions on the end. Host in lowercase. Lowercase is important. If you were going to just put it in your current directory, then you could put ./host. But rule of is you always put it in an inventory file, so they're easy to find. And then you can go through and read the rest of these things. Host underscore key underscore checking is false. That means don't make it do that RSA stuff that we see every time and to look for the fingerprints. Just skip over that. Okay. The next one, how many times do I want to set the retry up? I'm going to set it to be false. So it's going to run one time. If it doesn't work, it's going to tell me. Okay. That just takes more time if I made it retry 3 times or whatever. Forks, the maximum number of connections that we can make. So I can make, if it's set to 20, that means I can connect it to 20 devices at one time, and make it configure 20 things at one time. Now, Ansible, the way it works, it's not concurrent connections. Okay, it's going to run contiguous connections. So I'm going to run the first play that's there, and I'm going to do it for everything until it's finished. And then I'm going to run for the next device and the next device and the next device until all of my devices finish those. So it may take a long time. If you got a lot of stuff, a lot of devices to configure for the play to finish, it may take 30, 45 minutes. It is what it is. We're not going to do that many. When we do 1 or 2, 3, 4 devices, that's going to do that in just a few seconds. You might wait 15 or 20 seconds for it to finish. So that's really not an issue for what we do. The solution to doing that is we use a program called Nornir. Nonir. Nornir is the way they pronounce it. And it will run the concurrent. So if I do 20 things, it's going to run all 20 of them at one time. So in theory, it runs 20 times faster than Ansible does. And it uses YAML and Python, same things that we're used to seeing already. So it's no big deal to use that program. There is a document in the stuff that I gave you about how to use it. We want to set the interpreter. So yes, we're using Python. So where is Python located? We're going to tell it to do that. We're going to go tell it to these action warnings. So if this is telling us Ansible's got a warning about something, just turn it off. I don't want to see the warnings. All the statements about, oh, that file is depreciated. I don't want to see that. Just turn that off. And then this callback plugin. So when we get ready to display something on the screen and we save it into a variable, it's going to save it and display it back to us in YAML. What that line's going to do. This bin Ansible callbacks, then that's going to be when I run a command, instead of running a playbook and doing stuff, I can run individual things and have it return something back to me. Maybe I'm going to ping or something like that. So that's what allows me, this callback, that's what allows me to do a ping command. The SSH, these are the things we talked about this morning, or yesterday, sorry. Ansible SSH common arguments equals the -O, and then the gig rhythm, whatever, and then I could do the -O for the home directory, whatever that home, I don't remember what it was. You can add all that kind of stuff inside of here. So that's a good place to put it. So I personally, when I write that one, I put that one in the main.ssh.config folder. Then I write it in here just so I got a backup. In case one of them fails, I've misspelled something in here. It'll back up and it will run from the other one if it's all correct. I got information about all this kind of stuff and what you can add to it and things like that. But that's the main thing that we're going to look at. So that file, again, if nothing else, you just copy and paste that over into something that you call ansible.cfg. You're golden. All right, the next file that you have to create is the host file. the host defines the name of the device, the IP address that it's going to be in. We might put a loop back on there and set up an address. We could set up the interface addresses that we want to put into. We can put all kinds of things that we set inside of that. It always starts off as R1, and then we have Ansible _host, and then colon the IP address. That does not look right to me. I think that should be Ansible _host equals and then the IP address. I don't think it's a colon. I need to go. I think I've changed that once already. I guess it got saved right. So this is individual items that we're going to run. I can group those items together so that I run them at once. So I'm going to create a group called routers, and I put that inside of square brackets. And now I can just say when I run my playbook, routers, and it will run every routers all of them that you have listed in here. Or I can still just say router R1 is all I want to run, or R2 is all I want to run. Or I can group them together. I can create a group for switches, run them. I can create a group for Dallas. I can create a group for Texas. I can create all these different types of things that groups routers. So in this office, I'm going to run all these devices. In this remote office, I'm going to do this. In this office, I'm going to do this. And I can set all those things up. Then I can say, hey, no matter where I'm at, run all the routers all at one time. Whatever you wanted to do. I can nest groups together. So this is one that we very commonly will go in and do. So I'm going to nest it, and I'm going to call it Cisco : children. And then underneath that, my children are called routers and switches. And now I have a group called routers with R1 and R2 in it. I have a group called switches with S1 and S2. So when I playbook, I can say routers, I can say switches, I can say individual devices, I can say Cisco, and it runs all routers and switches together. So I can group those pretty much any way. What you see right there under that nested group, that is a pretty common, that's the way we normally do it. But it doesn't have to be called Cisco. You have to have the word children at the end of it. But you don't have to call it routers. You don't have to call it switches or R1 and R2. You can give it whatever name you want to. Make it meaningful so you know what it's doing, so not like I've done here. You can store different types of variables so that you don't have to put them in that line with your R1 and IP address and stuff. I could put some variables in there, and I'd have to do it every time. So I'm going to put the variables inside that host file still. And I'm going to call it Cisco : vars. So everybody in that Cisco group is going to get these variables applied to them. First one, Ansible _connection equals Ansible.netcom.network _CLI. So that's all that line is doing it is I'm going to go use something that's built in called netcom and allow me to run this through a CLI interface. Network or Ansible Network OS is Cisco.ios.ios. So that's the group of commands that we're going to make it run. Ansible _user, here's the username. Ansible _password, there's the password. Ansible become equals yes. Do I have the right to enter privilege mode? So it's like setting in your username, Scott, privilege level 15, password, whatever. That's doing the same thing. Can I get to level 15? Okay, so I can say become yes. And then to become method, I have to type the word enable. And when I type the word enable, I got to set the secret password class. So I apply that so that those variables work on every device. I can put those in their own separate file if I wanted to. So I could call this cisco.yml. And then inside my host files, I could say, hey, go use the variables in cisco.yml every time. So I'm not dependent on just that one host file. The variables, I could do it over every file if I wanted to. When I do it, I just set the variables in the host file every time. That's not hard just to get that information. So this talks about the enable command and what it does. By default, you don't have to tell your device to enable. So if I'm going to tell it to configure something, it automatically, because of that become in privilege mode and all that stuff we just set, it automatically will do enable for me anytime that I need to do that. It'll automatically go into config T, so I don't have to put that inside of it. When I tell it to do something, it automatically goes to that mode. And again, this is telling you about the privilege stuff that what we just talked about up there. All right, next play is about the playbooks. So again, playbooks are written in YAML. So I have to have those 3 dashes first. And then here's this playbook, kind of what we seen a while ago. So switch backups, okay? So host, switches. I could say backup routers. So host, routers. Backup everything. Host, Cisco. Gather facts. When we do routers and switches, we can set that to no. Gather facts means get me the information out of that computer so I know what default stuff it is. What is its default IP? What is its default username and password? When we do and we configure, say, Raspberry Pis, or you want to configure a Windows computer, or a Mac, or whatever it is, another Linux or something, we usually have to have the facts first. For routers and switches, that's going to be no. And then the connection type, remember we told that a while ago, the connection was going to be network.cli. So we're telling it, hey, go grab that variable from that net communication. And then the tasks, the playbooks that we want to run. So the first playbook here, I'm going to set 2 VLANs. So I'm going to say cisco.ios.config, And then I'm going to say line. So I'm going to put multiple statements in there. So in a list, VLAN 10, name management. VLAN 20, name sales. And then save it. This line tells me save it when that file's been modified, save the configuration. So it'll take itself to the end. Take itself to the end, copy, run, start. Here's a play that shows commands. So set ios_command and then commands equals or a colon. And I'm going to tell it show clock, show host, show interface status, only the included connected, show VLAN brief, show spanning tree active, show MAC address table, dynamics. And then the register is just means variable. Set up a variable named show output. So save all that information into this variable called show output. And then the next one is a play that tells me, how am I going to save it? I'm going to save it to a backup. So I'm going to tell it to copy I'm going to copy the contents of that show output, and copy the contents, and then equals double squiggly brackets. You don't have to have a space here. It just makes it better, easier to read. And I'm going to say show output, when I set that variable, or any name that I set it to, dot standard output. Remember, that was one of them that we did, says turn it into YAML. And then I'm going to put a pop, that straight line's called the pop. That means run another command as part of this. So I'm nesting these two commands together. And I'm going to go find something that says to_nice_YAML. So YAML, usually when it prints stuff out, it's just a line of code or straight across line of code. This is going to automatically do the indents for me where there's an indent where the indent should be, and make it 2 spaces or 4 spaces, whatever you want it to be. And then I can set the width to 80. Wherever you can see that. So set the width to be 80. And then in the parentheses, and then double in the square brackets and in the quotes. And then on the next line, the way it's still indented, destination is a folder called backups, / and then in double squiggly brackets again, inventory name. So whatever you call that device in your host name, R1, R2, S1, S2. So I'm going to call this first one, if it does it, R1.config.text is then what I'm going to name it. And the way it's going to save everything at show output, now it's going to be saved in that to_nice_YAML format, and it's going to be saved into router1-config.txt in the backup files. And then if you want to have this, you don't necessarily have to have it, but I can say check and be sure the startup file now is identical to the running config. So cisco.ios.ios_config diff-against::startup. So it knows the file that the running config, it knows it by that iOS config, diff config, and then match it against the startup. If it's startup and running config are not exactly the same, it will tell you, hey, there's a problem. It did not work correctly. And I do this, when I do this with my students, we do this early. I actually do this first semester pretty earlier in the year. And they learn how to use a GitHub. So they go in, and when they do an assignment, a project that they're going to do for me, that they're going to turn in for the grade, then we've got a little playbook that we pre-build. It's the same one every time. And they run that playbook. It saves out their configuration files, and then they copy those configuration files to GitHub. And then I can download it. I can grade them from right there. I actually have a diff program that I called it that goes through against my master file that I know that I put every command in that I want to grade them against. And it goes into their file then and see if they have the same commands the way that I have them, and then grades it and puts it in a Excel spreadsheet. So I don't have to, I just click one button and it grades everything in that folder. So that saved me a lot of time. I'll be glad to share that with you and show you what I did if you're interested in that. So that's the 3 kinds of files that we're going to run. The config file, the host file, and the playbook. Again, this one may be I'm installing a web server to run something. So this one's installing Apache. Tells me what's if I got more than one device out there. Well, what's its operating system? Oh, it's a Debian base. Oh, okay. This is what I need to run. If it's CentOS, oh, I got to run Yum to make it package manager. I can create some loops. So I can do a little bit of programming in there. So I can set the IP address, item via CLI, Cisco config, and then say lines, IP address, items, with items, show the loops is what they were called. So it's going to go up and find, oh, here's loops that's in a file somewhere, in our host file, and run this on both of these loops. So put the IP address on the loops. Here's the validation. If I was just going to run, I didn't put that diff inside of it. So run the Ansible playbook, whatever you called your playbook.yml, check it, run diff against it. See if there's differences in them. So this talks about doing some Raspberry Pi stuff. So this little script right here goes into Raspberry Pi and expands its file system to the size of whatever disk that you have in it. So if you put a 32 gig SD card in, now your disk you can access all 32 gigs of that and store information into it. Here's some debug command. So message is just says the IP address for router 1 is, in this case, tell me what its loopback is. These are all, this page just goes through and tells you what all of the Cisco iOS commands that are available to you. And it's listed there so that you can actually go out and see more information about all of those. Again, those are the iOS.iOS config. That's the one that we use the most. But if I'm going to do something with just OSPF, I can specify just that. If I want to do something with just layer 2 or just layer 3 interfaces, I can do all that stuff. Set up that variable routing and forwarding. This is one of the commands that we're going to want to install. Galaxy-collection, Ansible-Galaxy collection install Cisco.iOS. That's how we get the Cisco iOS installed. And then we can name it. That's what our collection's name is going to be every time if we did it. Here's one that's going to use that iOS L2 interfaces. So this is setting up trunks. All right, the SSH that you need to put on there. As I told you yesterday, Cisco uses these two Hellman-Diffie key structures that's not supported natively inside of Linux anymore. So you have to go tell it, allow these two, install these two so that they work together. So you can put that several places. My suggestion is put it in this, go create this .ssh file. So you're going to have to go into your terminal inside your home directory. So I could put mkdir, make directory, ~/.ssh. I can cd into that or say the word touch, since this is a file. MK directory for that, touch, nano, that kind of thing starts it. So you would probably want to do nano, sudo nano if it requires that, and then set that out and open up the config file, put this information in it. These two have to be indented. This is all on the same line as the KEX algorithms. And then save it. It's going to save it in that location. Again, it'll tell you about some of the other options that you can do. So here's a way you could set it inside of the routers group. So I could set it on the individual device, Ansible SSH common args, and then write it all out. I could set it in the variables in the host file and do that same thing. So 3 ways. You put it directly on the device command. I can put it in the variables command. I can put it in a separate SSH. You want to do it all 3 ways? That's great. When I do it just to double check myself, I'll have it set up in the config file. And then I usually put it in the variables too, just so I got 2 ways of doing it, just in case. Keep something from erroring out. All right, and then you have some ad hoc commands. So these are things I can run without having to have a playbook built. Okay, I'm going to run them through the Ansible service, but without a playbook, or with a playbook if I wanted to do that. But these ad hoc means without a playbook. So I can go to Ansible and say group. So routers -M, that tells it to execute this, forget what the M actually stands for. Anyway, -M, ping. So it's going to go into that group, find its IP address of the devices that are listed, and ping them. Because it pings through the command prompt, because it pings through SSH, because it pings through a router, doesn't mean that it's going to work inside of Ansible. So that's a good thing to check yourself with. Ansible, whatever, Cisco, and run everything at once, -M ping. I use that one quite a lot on new devices. If I just want to reboot, then I can tell it reboot all devices. Bin, reboot. You can transfer files, create new users, delete users. We can do all kinds of things through here. Start and stop the service. All right. Almost to the end. So let's talk about now, how do I get Ansible installed? First thing you need to do is, this was run on 20.04. It's the same thing if you're running 22.04. That's what I'm on. If you're doing 23.10, that's fine too. It doesn't make any difference. Okay, finds them all the same way. So I'm going to copy, for me, I'm going to copy this whole little section right here. This is 1 line of code, but I couldn't see it on 1 line. So that double ampersand means new command, and then the backslash says move to the next line. And notice that it's indented. And now I'm going to run sudo out install software property commons. And then I'm going to run this repository command. So this is what gets Ansible on mine, so that in the repository, so that I can install it. And then I'm going to run this update and upgrade again. Let's see if I can make that work without any errors this morning or today. All right. It just went and installed all those dependencies for me. That quick. Unless you're John sitting here and it would still take him an hour and a half to finish up. Yep. All right. So now I got that dependency for Ansible there for me to look at. So now I can run the command. I could have put it up there with the rest of them. Sudo apt install Ansible. I put the -y so that it doesn't, I already answered that yes question that it's going to ask me about. Okay, sudo install Ansible. Looking for the latest, greatest version of it. Now we got the progress bar, means it is installing it. So you can go back and run that install program in a few months and you may get a better version. Then we seen on the computer back here, John's on, that he was running a Python version 3.10.6. And I can do an update and get to 3.10.10. or 3.10.11, something it'll upgrade it to a higher version of that. There is 11 now. It's rewritten. It's causing havoc for a lot of places. I would not upgrade to the 11 yet. Give it a few months to settle down, and all the PIP won't work correctly now. So all those things that we're using, NetMeco and stuff, they don't work the same way. So give that a few months so we can all somebody can figure it out and tell us. All right, I got all of that Ansibles now installed. I can check, see if it is correct. Run that, is it? Yep, so we got a response back. I'm running Ansible 2.10.8. Config file? No, there's no config file in there yet. We're going to take care of that here in just a second. All right, now I need to install that Cisco iOS commands. So Ansible _Galaxy collection install cisco.ios. Checking on the dependencies. All right, it's downloading it. Installed successfully, version 2.10.11. Great. And Ansible is done. It should be up and running. So first thing I'm going to do is go create a directory for right now called My Ansible. And then I'm going to move into that directory and create two more. It's called Backup and Inventory. So where I'm at right now, I'm in my Python. That's okay for me to put stuff in there right now. So I'm going to say mkdir and My Ansible. Got it right. And then I'm cd into My Ansible. Oh, I didn't put the dash. And now I'm going to create two files. I can move into them, or I can strictly just to create it without opening it. I can say touch. Oh, excuse me, I'm not making files, I'm making directories. mkdir, backups, and I can do the same one in here, inventory. Do both of them at one time. Return, ls. I see backups and inventory, my two folders. So now I'm ready to start building those three types of files that we're going to do. So the first one I'm going to do is my config file. Okay, so I'm going to tell it sudo nano, and I'm going to go to my home directory into a .ssh.config. And when I get ready to save that, it's going to tell me, oh no, you can't do that because you don't have those directories set up. So I need to set up that directory structure first. So I'm going to say sudo mkdir // And that exists for me already. Great. I already put it in there. And now I can do the up arrow twice, nano into that file. And you see I've already written it in there. So that's those algorithm things that we need to do. All right. Now we need to create the CFG files. So I can, again, put them in several different places. Let's go back and look at that. Let's build this. This is just going through another practice exercise so that you can go through and see if you can set all this stuff up. So you can go through and do that one after you played with it a little bit. Let's go back up there where we got all the other stuff. We just created that. And into that config file, there it is. So I'm going to put it in my Ansible config. I could put it anywhere of those 4 places that I want to do it. So I'm going to, for grins, I'm going to go ahead and put it in that Ansible config file. I'm going to copy that. I'm going to go back over here to my Ubuntu, sudo, nano, and paste in that. All right, that opened up. So I want to get all of this default stuff, everything that's not bigger, smaller, so I can get it all in one screen. So everything from there to there, I want to copy and paste inside this playbook. So again, everything's, I got, and we were John and I were discussing this earlier. When I do this with students, I give them a paper copy of this lab so that they have to copy every command. They can't copy and paste out of it like I'm doing. I want them to copy every command. You learn it faster, you memorize it better, you remember them when you're doing, instead of just copy and paste it. Okay, and that way it makes them be able to troubleshoot and check. You know, if they misspell one thing somewhere, it doesn't work. So they got to be able to go back and find that little mistakes. So it really helps with troubleshooting stuff to do it. All right, so I'm going to save that. All right, no such directory out there, it says. Okay, well, we need to make that directory structure. So I got to get out of that without saving anything. And I'm going to sudo make directory. And it's going to be the .etc/Ansible. All right, made that directory. So now let's go back in there, paste it in there again, and save it. We're good to go. All right, so we got our config file built in one place. Let's go ahead and do it for grins. Let's make some backups of that. So if you remember, it said we could put them in any of those places. Let's just create the one that's in our current directory that we're in. So I'm going to do nano, and again in our current directory. So that big long string in that my Ansible, I'm going to say Ansible-CFG. Paste in exactly the same variables and save it. Now I got a backup copy. I can go look Ansible-version. Config file. Oh yeah, now I have a config file. It said none a while ago. Now it knows that I have a config file there. So good to have backup copies of stuff if I need it. All right, we're finished with the config file. Let's go grab the routers and switches that we're going to do. So again, I'm going to just copy and paste it. So I'm going to copy out that place. I'm going to put this as my host file that I'm creating. So I'm going to go into nano in this location, and I got to go into inventory, host. So I've got to save it inside of inventory and paste in that information. We'll save that for right now. And then I'm going to go back over in there. I'm going to go down and grab all of the variables. And let's get back into our host file. Move my cursor down to the bottom. Paste in that information. Got too many lines in there. Yeah. And you nearly always want to have just one blank line at the end of it. Don't know why that makes a difference, but sometimes it does. All right, save that. All right, we now have a host file built. And remember, because in the config file, we put that the inventory was inside the host file was inside of inventory. So that's why we had to do it this way. If we go back and change that config file, so we could change the local config file that's in the folder to be something different now, but it would always default, if I didn't put it, it would fall back to that inventory every time. Or wherever I decided to put it. All right, we are ready to build some playbooks now. So again, this is just a little backup one in its entirety. So I'm just going to go ahead and copy that particular playbook. And now I'm going to go nano and whatever I'm supposed to name it. I didn't look at that. I'm going to call it backup switches. So nano backup dash switches dot YML. I could put YAML, but it's better to put the 3-letter extension than a 4. And paste in all of that code. Now notice when it does pay, because I took it out of PDF, it just posted everything in one line. It didn't do any of the indents for me. Didn't line anything up for me. All right, so we are ready to run it, see what it does. So, Ansible dash playbook backup colon switches dot YML. So had some type of an error. Empty local host is available. Can't read my JSON or YAML file. There are errors in it. And that partly could be. Well, I have nothing to help me tell me what the errors are. That's kind of a pain sometimes. So let's go back and let's go fix that now. So I'm going to go from my location that I'm in right now. I'm going to go type code space period. Yes, I trust that location since it's mine. All right, so I can see I'm in my inventory. So I'm going to go, let's just go check and see what it is. So I'm going to go to my ansible.cfg and run it. It would tell, if I got errors, whoop, down there at the bottom, it's telling me this. Nope, that's not an error. That's telling me just a different color. So no errors that show up there. Probably it's I'll look in the inventory. There's the host file. Nothing necessarily in there. I'm gonna space those out. Not that it makes a difference, but honor switches, things are named correctly. That all looks good. Save that one. And let's open this backup YAML file, see if it says anything. No errors in there. Let's see if we got some extensions. Let's go to Python. Error. I'm going to install that one since a million other people have. Let's run that and see what happens. All right, you have the rest of the afternoon to work on finishing up your Ansible, whatever you can need. Please contact me if you have any questions about it. Otherwise, I will be talking to you, ladies and gentlemen, later. Have a good day.